You see all these rockets launching constellations of satellites into orbit, and with all that excitement, it's easy to think the future of the internet is just beaming down from the sky. That maybe, just maybe, this brand new tech is going to finally replace all those old cables in the ground.
And that's a great question, right? It really points to a huge potential shift in how we all get connected. But is that what's actually happening? Let's dig in and find out. Because here's the wild part. For all the talk about the cloud and wireless everything, the internet is a deeply, deeply physical thing. When you stream a movie, that data isn't just magically flying through space. Nope. It's being blasted as pulses of light through these impossibly thin strands of glass that are buried deep underground and stretch for thousands of miles across the dark ocean floor. So to really get why that is, we first have to look at what's actually holding the entire internet together.
This is what they call the internet backbone. And it's not some abstract concept. It's a real physical network on a scale that's just hard to wrap your head around. Think of it like a global superhighway system just for data. And here's the thing, every single piece of wireless tech, your 5G, your home Wi-Fi, and yep, even the most advanced satellite networks, they all have to plug into this physical fiber backbone to talk to the rest of the world.
This chart, wow, it really puts it all in perspective. The numbers are just staggering. According to the FCC, over 99.6% of all international data travels through these undersea fiber optic cables. And satellites, they're carrying less than 0.5%. I mean, this isn't even a competition. It's a total knockout.
So why? Why is there such a massive difference? Well, it all comes down to the fundamental physics, the engineering, and of course, the money behind these two systems.
Okay, this table really breaks it all down. Just look at the raw numbers. For throughput, which is your speed, fiber gives you these symmetric speeds. Your upload is just as fast as your download, and we're talking gigabits per second. Satellites, much slower, and you have to share it. Then there's latency. That's the lag you feel. Fiber is almost instant. And check this out, the lifespan. A fiber network can last for 40 years. Those new low Earth orbit satellites, on the other hand, have to be replaced every 5 to 10 years. It's a completely different league. But the biggest difference, the real game changer, is raw capacity, what we call bandwidth. A single satellite can handle gigabits of data a second. And that sounds like a lot, right? But a single fiber optic cable can handle terabits, even petabits. That is 1,000 to 1,000,000 times more data. The scales aren't even comparable. And here's the number that just blows my mind. A single strand of fiber optic glass, thinner than a human hair, has the theoretical capacity to carry 600 terabits of data every second. Now, to put that in perspective, the entire current Starlink constellation, with all of its thousands of satellites, has a total capacity of around 300 terabits per second. So one single strand of glass has double the capacity of thousands of satellites flying in space. That's the power we're dealing with. So really, the best way to think about it is this. Fiber isn't just a faster road, it's a massive, multi-lane superhighway system with an almost unlimited speed limit. Satellites are more like narrow bridges. They are incredibly useful for getting to a place that no road can reach, but there's no way they could ever handle the traffic of a major city.
And on top of that, those bridges have some real challenges. Satellite signals are prone to rain fade, where a heavy storm can literally just block your signal. The orbits they fly in are getting more and more crowded with space junk. And because that bandwidth is shared over such a huge area, they get congested really easily in cities. You just can't serve thousands of people in a dense neighborhood with satellite the way you can with fiber. And all of this leads to a totally different economic reality. Sure, laying fiber is a huge upfront investment. It's expensive to dig trenches and put cables in the ground. But once it's there, that asset lasts for decades with incredibly low maintenance costs. Satellites are the exact opposite. They might seem faster to deploy, but you're locked into a never-ending, incredibly expensive cycle of building, launching, and then replacing them. You're on a permanent maintenance treadmill.
So if satellites can't possibly replace fiber, then what's the point? Why all the investment and excitement? Well, that's where the story gets really interesting. Because it turns out this whole time we've been asking the wrong question. It was never about fiber versus satellite. The real future is fiber plus satellite. They aren't actually competitors fighting for the same turf. They're more like specialists on the same team, built to solve completely different problems.
Look at it this way. Fiber is the undisputed workhorse. It's the global backbone, and it's perfect for serving our data-hungry cities and suburbs, where density makes it the only logical choice. But satellites, they do the impossible. They're the final frontier of connectivity. They can reach remote homes, ships crossing the ocean,
airplanes at 30,000 feet, and they are absolutely critical in disaster zones when the grid on the ground is gone. They bring the network to places it could never otherwise touch.
If you only remember one thing, let it be this. Fiber optics are the power plants and the massive transmission lines of our global data grid. Satellites are like portable generators. You'd never try to power an entire city with generators, but they are an absolute lifesaver when the grid can't reach you. It's that simple. Satellites extend the network. Fiber is the network.
So let's circle all the way back to our original question. Will satellites replace fiber optics? The answer is a definitive, resounding no. Satellites have a brilliant and absolutely essential role to play in connecting the unconnected and making our global network stronger. But the foundation of our digital world, that invisible bedrock carrying the massive amounts of data that define modern life, is, and for the foreseeable future, will remain pure light, traveling through glass.